Okay, so we go to, I want to do 3c. So we have the integral from -1 to 0, and then dx over 3 minus 2x minus x squared. So dx so this is 3c. The integral from -1 to 0 dx over 3 root minus 3 minus 2x minus x squared. Three minus 2x minus x squared. Okay, so the first thing we do is, now we get in the root, and we write this guy in this form. And then complete it, complete the square, so we can tell what form it's going to be. So we're going to have a negative, and then x squared plus 2x plus 3. That is x plus 1 squared minus 1 plus 3. So this is going to be x plus 1 squared negative plus 4. Meaning, when we come back here, it's going to sit as dx over the root of 4 minus x plus 1 squared. You see? So when it is like that, you check which form are we in, the constant first. So it's either form 1 or 2. This is 1, this is 2, this is 3. It's either form 1 or form 2 because the constant is positive there. So now it's form 1 because we have a minus. So we let the whole x plus 1 to be equal to a sine theta. Now what is our a? Our a is 2. So it will be 2 sine theta. Then quickly, we get dx, which is going to be 2 cos theta d theta, like that. And then we come here now and say, okay, or maybe if I went to the triangle quickly, I'll have sine theta is equal to x plus 1 over 2. So my triangle in advance is going to look like this. That is theta there. Then we'll have sine is opposite over hypotenuse. So this guy is going to be 4 minus x plus 1 squared. And then now we can go this side and say, okay, so what we have is the integral with those limits. And then we are having a dx, which is 2 cos theta d theta over the root of 4 minus, when we square the x plus 1 is going to come out as 4 sine squared theta. So that this gives us from -1 to 0. It gives us 2 cos theta d theta. And then we pull out the 4. It will come out as 2. And then we have 1 minus sine squared in the root. which is cos squared. Its root is cos theta. So you see, this part and that part will cancel. We end up having the integral from -1 to 0 of d theta, meaning of 1. So this guy becomes what? It becomes, what's the integral of 1? The integral of 1 is theta. Okay, now remember we didn't change the limits. So because the limits were not changed, we need to change this theta into the x. So theta is going to be sine inverse of what? X plus 1 over 2, substituting -1 and 0. So this is going, you put 1 here, you get sine inverse of half, which is 30 degrees, minus, when you put -1 there, you get 0. Sine inverse of 0 would be so many angles, but we'll go for 0. Okay, so that this gives us 30 degrees. Since theta is supposed to be the angle. So easy there.
So,
Mm-hmm.
from the square root of 4 minus 4 sine squared theta, how have you calculated for you to end up with 2 cos theta in the denominator?
Because this was to be written as what? As the root of 4, 1 minus sine squared theta, is it?
Yes, sir.
Then the root of 4 is 2. Then 1 minus sine squared theta is cos squared theta. The root of that guy is cos theta.
No, okay, sir. Thank you.
So that's why there's always this A. This A. This A is to make sure that it responds to the constant that's there. Because whenever that is done, then we're able to get the root of that constant. Because when it is squared, then we have those numbers come out of the root. So that remaining the identity. You see? So we got to another one. So let's see one which doesn't have a root in the denominator.
Oh, sorry, sir. Just go back to the previous page. I just take a screenshot.
So this is a must question in the test. That's why I've taken my time
All
here
right,
because
thank
it
you.
will appear in the test and in the exam. You have to do the substitution, either trig or hyperbolic or both. So though we haven't used hyperbolic because it follows. Okay, so we go to the next one. This is x over x squared plus 4x plus 5. x squared plus 4x plus 5 dx. So what happens here is that we again go straight into the denominator part and do the completing. So it's going to be x plus 2 squared, x plus 2 squared plus 9. When you complete the square down there, so I'm going to have x over x plus 2 squared plus 9 dx. So now I want to change things. Though even if there's no root, so since we have a plus, so let x be a tan theta and see how things will unfold. So I'm going to have let x be 3 tan theta. So that when you differentiate, we get 3 sec squared theta d theta. Then we come here and say our x is 3 tan theta. Our dx is 3 sec squared theta d theta. Over, down here we have x plus, oh, okay, no. Before this step, we need to write this as, x plus 2 equal to 3 tan theta. And then dx equal to 3 sec squared theta d theta. Then now we can substitute. So we have x is equal to 3 tan theta minus 2. Dx equal to 3 sec squared theta d theta. Over x plus 2, that becomes 3 tan theta, and then we square plus 9. Meaning we're going to have up there, we can do, or maybe before we do anything, we can just write it the way it is. For something is going to happen here. So we have this 3 sec squared theta d theta over, this becomes 9 tan squared theta plus 9. If we factor out 9, then we'll have, there's a 9 up there, 3 times 3, that's 9. Oh, sorry, it's not 9. The 3 is not as I've mentioned it. We have a 3 tan theta minus 2. We leave it like that. And the 3 sec squared theta d theta. We're dividing by, we factor out 9. Then it will be tan squared theta plus 1. Yes.
Sir.
Hello.
Sorry. I don't understand how we have that numerator there. How x has become 3 tan theta minus 2. Then this squared theta. I don't get that bit.
Okay. So look what's happening here. Here we are saying, we first completed the process. We have this, okay? after you complete the square, then now this whole x plus we are trying to compare whatever we have to these three forms, form 1, 2, or 3. So which format do we have? Though we are not in the root, but we'll still use this here to say, okay, since I have the constant squared plus a variable squared, then my substitution would be best if I let x to be the constant tan theta. Now, the x that we have is not a single x. It's the x plus 2, whatever is in the square. I mean, whatever is squared is what we are relating to our constant tan theta. So we get the whole x plus 2. So we get the whole x related to tan theta.
So I don't know if you're far from your microphone. I can't hear you clearly.
Okay. Maybe now I should hear me.
Yes, I can.
Okay, so we let the x plus 2 be equal to the 3 tan theta. Now from there, we want x so that we take in the denominator there, where there's x. So we make x a subject. So we'll have 3 tan theta minus 2. You see that?
That's what you think, but that's not the case.
Then we want this dx. So we differentiate this x. To differentiate tan, we get sec squared. The minus 2, the derivative of a constant is 0. D theta. So now we go and substitute. Where there's x, we'll put this whole thing. Where there's dx, we'll put this whole thing. And that's how come we have that numerator there and that denominator there. And then after the expansion, we arrive at this point here. So now what is tan squared plus 1? It's what? It's sec. So we'll have this over 9 tan squared theta plus 1 is sec squared theta. So this part and this part will cancel. This 3 and this 9 will reduce. So we are going to have 1 over 3 and then 3 tan theta minus 2 d theta. Then from there now, I can express this as the integral of tan theta minus 2 over 3 d theta. So I should be fine now.
Kindly mute your microphone so that you can hear what the says. Kindly mute your microphones. Thank you.
Okay, so what's the integral of tan?
Before we...
So the integral of tan is what? It's ln sec theta and then minus 2 over 3 theta plus c. But remember, the answer cannot be expressed in theta form. It must go back to x. So we also make a triangle here, where this is our theta and our 90. That is tan. So what is tan theta in this form? Tan theta here is x plus 2 divided by 3. So tan is opposite over adjacent. So it's x plus 2 over 3. So that this guy here becomes 9 plus x plus 2 squared. And now we want sec. What is sec? Sec theta, this is 1 over cos. So where cos is adjacent over hypotenuse, sec is hypotenuse over adjacent. So it's this over adjacent. We are going to express in that form. So it will be lean root of 9 plus x plus 2 squared over 9 minus 2 over 3. What is theta? Theta is going to be tan inverse of what? X plus 2 over 3. And then plus c. This will be the solution. Questions?
So just go to how you did the triangle again.
Hello?
The triangle. How you
So the triangle, you form the triangle using the relationship of tan. So from here, you express tan as the subject of the formula. So you have tan theta equal to x plus 2 over 3. Then quickly remember that we are going to use SOHCAHTOA to form the triangle. So tan is opposite over adjacent. So when I form my triangle, this is theta. So I go opposite, that's x plus 2. Adjacent, that's x. In order to be hypotenuse, I use the Pythagoras theorem, so it's going to be the root of what? 9 plus x plus 2 squared. That's how we form the full triangle. Then now we need to get sec. What is sec? Sec is 1 over cos. Okay, so if cos is adjacent over hypotenuse, means that sec is hypotenuse over adjacent. And then we pick from the triangle to substitute, because your answers must never be left in theta form. They must be left in x variable. That's always key. So you leave your answers in x variable and not in theta variable at all times. Okay, so you guys can try out these questions on and by using hyperbolic substitution, because they work in a similar manner. I've given you the identities, all of them. This is the key thing to note. This here. Any test you write with this coverage, this question cannot miss. That's why we've invested our time in this question, because we are sure that it will be there. And so you must be able to answer it. Both in test and the exam. Okay, let's go to question Question 4. Question 4 is talking about evaluate each of the following integrals. And then look at how it is. You see? So here we use partial fractions. Here we use partial fractions. So which one do we choose? Let's choose one. Let me give you the power to choose. You can choose one or two. Anyone to choose?
A and D.
A and D.
And D.
Okay. Let's start with A. So we do A. Where's my trash sheet? In the phone, so that I don't come back. Okay, so we'll start with A. For A. So we have the integral of 49 x power 3. 49x squared, I mean, minus 19x minus 18 over 12x power 3 plus 13x squared minus 20x plus 4 dx. So these partial fractions demand that we first factorize the denominator. The denominator factorization, remember it's a polynomial, so we need to try zeros here. So if I try 1, can 1 give me a 0? No, because it will be 12 plus 13 minus 20 plus 4. That can't be a 0, right? And no, it cannot. What about a negative 1? It will be negative 12 plus 13 plus 20 plus 4. No. What about 2? Is there even going to be 0 here? What about 2? 2 is going to be 8 by 12. I need a 0. 8 by 12, that's 96. 96 plus. Numbers are becoming big so fast. Let's try minus 96 plus 4 by 13. That's 52. Plus 40 plus 4. I think this one is working, eh? Plus 40 plus 4, 96. Yeah, this is 0. Okay, better. So this 0, we've used what? We've used negative 2 to get the 0. So we go with -2 via synthetic. So I pick the coefficients of the denominator. So I have 12, I have 13, I have -20, I have 4. So we add a 0 there, we get a 12, multiply, -24. So we add, what's the 13 minus 24? It's -11. We multiply, we get +22. We add, we get 2. Then we get -4, we add, we get 0. Okay, fine. So this is going to be x plus 2. Since it's minus, it becomes plus inside. And then 12x squared minus 11x plus 2. Let's see the product for the quadratic. The product is 24. Two numbers, when we multiply, we get 24. And then we add, we get 11, -11. Let's see. Yeah, they're there. I think 8 and 3. Yeah, so I'm going to write this as 12x squared minus 3x minus 8x plus 2. So that we get 3x, then we have 4x minus 1 minus 2, then we have 4x minus 1. Yeah, good. So we're going to write this as, first we leave out the integral. We'll come back. Let's do the, okay. Let's get the integral since you're already done. For 9x squared minus 19x minus 18, we're dividing it with what? X plus 2 multiplied by 4x minus 1 multiplied by 3x minus 2 and dx. You see that? So now this should be written as, yeah, so first we keep the integral. Let's come back again. We write this as 49x squared minus 19x minus 18 equal to a multiplied by 4x minus 1 multiplied by 3x minus 2 plus b multiplied by x plus 2 multiplied by 3x minus 2 plus c multiplied by x plus 2 multiplied by 4x minus 1. You see? So now we are trying to hunt for A, B, and C. So of course, when x is -2, when x is -2, what happens? This would disappear and this would disappear. So we're going to have a -2 here, giving us -8, which is -9. And we're going to have a -6 minus 2, which is -8. So what is 8 times 9? Is 72. So we're going to have 72a equal to, when we press it, the -2 here, it becomes 4. Big numbers. That's 49 by 4, 196. 196 minus 36. And then minus 18. 142. This 36, no. It's 30. It's 38. 38 minus 18. Yes, 140. So this is 140. Not 140. It's plus 38. Yeah. Minus 18. So it's 216. So it's 216 is equal to 72A. So what is A? A is equal to this guy divided by 72. A is equal to 3. See? So I've gotten A, so I'm filling in here. I'm having the integral of 3 over x plus 2. Let's go. What will be B? So for B, big number then. Ugly ones. To substitute. Oh. Bad numbers. So what I want to do, I want to avoid these bad numbers I'm seeing here. So I don't want to deal with fractions. You get the point? So I'm going to use another way, another method. So I'll let x be 0. So that I remain with negative 18 on the left is equal to 2a minus 4b minus 2c. When x is 0, then the other one I'll use x1. So that I have 49 minus 19 minus 18 is equal to, when I have 1, that would be 3a plus 3b, and then 2 by 3, that is 6, plus 6c. Yeah, so let me work out the numbers. Remember, a is 3, so we're going to have a 6 here. Then it goes there said as a minus 6, so we're going to have minus 24. What is it? 18 plus 6 is what? Minus 24, yes. Minus 24 is equal to minus